Hello, folks, and welcome. Right now, I'm going to do a quick demonstration for a little concept that many students tend to get tripped up on. So we're going to be doing a little demo around locating the centroid of a triangle. Now, later on in the course, we're going to be focusing in on centroids and how we find centroids. Um, but this is particularly going to be applicable for distributed loads and where we're replacing a distributed load with a resultant force that must act through the centroid of that distributed load. So I'm going to share my screen here. And this is just this is just a piece of paper, and I just arbitrarily drew a triangle on it. We can look at this triangle whichever way we like. I can assure you I just arbitrarily drew this. And so many students find it confusing that the centroid of a triangle acts um, 1/3 up from the base or 2/3 up from the apex. So if our triangle is oriented like this means that our centroid is going to be somewhere that's going to be approximately 1/3 up from the base. Say, call that as about 1/3, and then 2/3 down from the apex. And so that means there's going to be some line that cuts across here, and our centroid is going to lie somewhere on that line. And so we're going to draw that line 3 times for all 3 different orientations of this triangle. And if I can do this accurately enough, these should all intersect. So the first thing I'm going to do is I'm going to measure this height. And this height really quickly looks like it is just over 9 centimeters. It's call that 9.1 divided by 3 is going to be basically 3. So we'll put that right there. And then I'm going to draw that same distance up here. 3. Just so I can draw a line through both of these points. And so this is 1/3. Okay, so we've got one here. Let's flip it this way. And we'll measure this height. This height looks like it's 14.6 divided by 3 is 4.9. 4.9 right there. I'll do another one over here. 4.9. Like this, such that this height here is 1/3. Now, if I've done this correctly, I should be able to do this one more time, and my next line should pass exactly through that exact same point. So the height of this one is 10.9 divided by 3 is 3.6. So from down here, 3.6, and go over here. 3.6. Now I'm going to connect these 2 dots. like so, such that this distance is 1/3. And so there you have it. I'm quite pleased with myself that this worked out pretty much exactly. I had to be really careful to be measuring accurately there. But basically, what this means is that if we have some kind of distributed load, we're going to represent the overall load as a single force that acts through the center. And so in most of our diagrams, we're not concerned with where it is with respect to the base. Oftentimes, our distributed loads are going to be high on one side and then low on the other. And so we're going to need to know where that is 1/3 from the one side or 2/3 from the other side, such that we can replace this force um, or replace the distributed load with a single force. And so there you have it.